so Roberto's got what we were building a transaction, right?
Yes, changing the faucet params of the faucet smart contract to faucet datum.
So that was it. Yes. So how far did you get with that?
So I'm up to the compilers. The problem is, can I share my screen?
Yes, please.
Okay.
And we're just, Roberto and I were just going to start early today to look at this together. But if there's something good for us to share, we can bring that into the main session in a few minutes too.
Just close this up. Can you see my screen? Is everything?
Yep, looks good.
Okay, okay. Just get this out of here. Okay. So this is the validator script, right? So what I did was, this is pretty much the faucet params. There's just the faucet datum now. And I changed the to unstable make is data. The validator is the same. This is the only part this is what I was talking about. I had made this, I had named this like faucet validator. And that was the reason why, I think that was the reason why it wasn't working here in this part. It was complaining about not being able to find this. And I felt it makes sense to me that you have to name it that way. I can't name it faucet validator here and name it MK validator down here, right? That kind of, I thought that was, and then, okay, so I got this far, that was working sort of okay. And then I get to this part and I'll show you, I have this running in another terminal 4. So this is my error now. It's expecting, this is pretty much it. I am getting faucet validator script, faucet datum to ledger validator.
Hey, Roberto, I can only see your VS code. I can't see the terminal window you're showing.
Yeah, this one. Just make this bigger.
That looks good.
Okay, so this is the error I get now from the compiler.
Yes, I think this is on line. And what does line 28 say? Switching back to VS Code again.
So
this line right here. Yeah, it can't match that.
Yeah.
Type. Right. Okay. First thing, so you changed make lift to make unstable data. I think you might need both. The make lift might be necessary in order to use it. Let's see if that makes the difference.
So when you say the make lift, is it just like do the same thing, just copy it down and just put this TX?
Bingo. Yep. Yeah. And this is, so Mix and I were talking about this the other day. He's been working on his short explanation of specifically what these two things do, because I don't feel like we've sufficiently talked through that yet. And I've been trying to do the same, but let's see what he's got for us today in terms of talking through that.
Okay. Let me check.
So yeah, let's see if that makes a difference first.
So just add the make lift, right?
That's it, yeah. And then reload.
Yeah.
And then recompile.
Oh, no way. Is that it?
Let's
No.
see. Okay, so that's the same error. Okay, so that's not it. The expected type takes a
So I don't know, closing again. So yeah, so it's the validator and the faucet datum as far as I can understand, because I'm grabbing both from here from this script, right? So it's
oh, I know what happened. Yeah. Okay, I know what this is. All right, let's go back to that error for just a second.
Yeah.
So the key part right? So where it says faucet validator script dot faucet datum arrow ledger validator, that's showing that this is like a parameter that outputs, we're adding a parameter and outputting a validator. But you don't have a parameterized validator anymore. So when it says with actual type, oh no, yeah, so the actual type of your validator is just a validator. And what you're passing it makes it expect to have this parameterized validator. And it's a little hard to talk about because it's almost like backwards in my mind, expected versus actual. But it's
like this is expecting an argument beside this, like this is a function and I should have given him a validator argument to this function. So then this could give it to the validator. Is that
it's actually, I think the solution to this is simply to remove, right? Because we don't need to pass parameters anymore. That's the other key thing to notice here, right?
Oh.
So we just want a vanilla validator. I think you can just delete everything in the compiler after, so in the compiler on line 28, that last $, just delete that and everything that follows. And then delete lines 29 through 35 because those are parameters, but we're no longer taking parameters. Now, let's try to compile this. I think we're still going to get an error because of now we're going to need to make a change to the script.
Okay.
But let's see what error this gives us now. Oh, that's all. Okay. Yeah. So.
Oh, I don't have to import the faucet datum from the faucet script.
Right. That's right. That's right.
I don't get why this worked.
Okay. So, yeah, because we're not, yeah, we don't need that there. That's right. It's just a validator. So we've been working with parameterized validators. Compiling those has the extra step of both defining what the parameter is going to be and then adding that at compile time. Let's look at the bottom of this script file just to make sure that there's nothing extra there, but it's working. So I don't expect to see this, right? So your typed validator is no longer doing the lift code step. So we can actually, right? So in the previous version on line 129, you would have seen that apply code step and then the lift code step, but you successfully got rid of that. That's great. So that looks good. And this also means that I was wrong. My first guess, just saying, hey, throw that make data or make lift data back in there, that's not necessary. So let's just delete that line that I had you add and see how it compiles. I'm assuming it should be fine.
Yeah.
Yeah, okay, good. Good. Yeah, so I would say this is ready to play with.
So the difference is, so how, when the previous one, we passed the parameters to, we passed the parameters through this compiler, right? No.
Yeah. So, okay.
Yeah, exactly. You can go to this validator function. When you go down, you have this here, typed validator here. Here you give the datum with it, I think. So the datum is also already in this typed validator.
Okay.
So you don't have to deliver it there, I think.
And
here is the validator function. When you go
so
down,
what about these values, right? Because how do we know? Oh, it doesn't matter, right? It's not parameterized.
Yeah,
Okay.
exactly. You said it
Okay.
at the beginning.
Okay. So that's the difference, kind of. It's a little bit more generalized. Is that the point?
Yeah,
Because
yeah.
I know we talked about
Yeah.
that this is the design decision, whether to use parameters or datum, but I changed it and I'm not really sure. So the only difference for me until now, what I can see is, besides the code that I'm using here, is I'm not passing parameters here. So that does that mean that where do I pass those values? Where would the program get the?
Yes. Well, so now,
You don't pass it. You have it in the contract, I think.
well, I want, yeah, which verb to use is complicated here, but so if we want to use the word pass to say, okay, I can pass parameters at compile time if I'm creating the script for a parameterized validator. But here, this is, Roberto, like you said, this is a generalized validator that is going to create a single contract address that is ready to handle whatever datum we throw at it. And so, first of all, just from the system level, if we take the parameterized validator approach, we're going to end up with a set of different contract addresses, each of which already baked into it, you have kind of the rules for interacting with it, right? I have to have this access token and that faucet token, and you can take this much of a withdrawal at the same time. How many UTXOs will there be at each of those contract addresses? Well, this contract is designed to insist that only one UTXO gets placed at the contract address after each transaction, but there's no real guards. Like, people could throw a bunch of other UTXOs at that contract address, and on the front end or the PAB transaction orchestration step, that would make our job a little harder if that happens, right? So there's kind of this contract address hygiene element that we have to think about when we're constructing transactions. So ideal, again, parameterized, ideal world, you got a series of different contract addresses, and each one has one UTXO at it that represents what's held in that faucet.
Okay.
What you have here is completely different. It's a single contract address that is designed to hold any number of different UTXOs, each of which represents a different faucet instance.
So I'm sorry for making this, because is this sort of like a constructor? Or like a prototype?
Yes.
In the sense that you can just derive, so you would derive smart contracts from this prototype, would you say? Or how does I guess, so every time I put UTXOs, or what is it? Say, yeah, I wanna place a UTXO here. What is the?
Okay. This is actually, we do need to cover this in a real live coding session. So this is great. We're practicing right now. Yeah, I'm recording. Good. I think it'll make more sense if we actually just see this in action. Okay, so let's just going back to the parameterized version, we really didn't use datum for anything. We just made it an integer. We hashed that integer and we attached that hash to the UTXO, but it didn't really serve too much of a purpose.
Oh, okay, yeah.
Now, the datum that we hash, first of all, it's going to be more complicated than just an integer. It's going to have to be this entire data type that you defined up starting on line 54.
Yeah.
it's we can create that, and then we can hash it. And so the logic we are checking against is gonna look at that particular datum and then use this information in the very same way. We don't have to change anything starting from line 71 and beyond, because just the way we're supplying this data to the validator, we're saying, all right, it's going to come from the datum instead of being baked into the contract address itself.
Right. Because
Yep,
in
go.
the previous one, so it's parameterized because, so the parameter, we had to change them here, right? If I wouldn't have changed it, that would have been the same contract. Whereas if I changed the parameters, that would have been a new one. Whereas this one, it's just going to take them and process them. It's not necessarily going to make a new contract address. Is that kind of the difference? Am I getting this?
Yeah, you've got one contract address that anybody can use. It really is open access. Nobody can stop anybody else from sending and locking funds at this contract address.
Yeah.
And when they do, if they want to use this correctly, they will have to attach the right kind of datum to the UTXO that's being sent to this contract address. So two things are true at the same time. One, anybody can send a UTXO here. They can lock up funds at this contract address that you've basically created here. Yeah. But then to unlock them, the only things that will be unlockable are those UTXOs that have the right kind of datum. And that datum will then dictate whether somebody can pull from the faucet what they're trying to get.
This data
Yep.
will dictate who can pull from my faucet.
Yeah. And your faucet as opposed to my faucet, the distinction between those is your faucet has one particular datum hash on that UTXO, and the one I created has a different datum hash on my UTXO representing my faucet. And when somebody comes along, basically they would need to know these values. Okay, so whether these values are supplied by our front end, or if somebody was just trying to do this via the CLI, they would need to know the currency symbol and token name for both the access token and the faucet token. They would need to know that withdrawal amount. And as long as they know those 5 things, they can construct a JSON data object, they can hash it, and then once you see that hash, you could just scan the list of UTXOs. Ooh, which one of these has the datum hash for these 5 parameters, right? You'll see they match, or obviously we can automate this, and you can filter through the UTXOs returned by a contract address and find the one with this particular datum hash. And then we can say, okay, that's the UTXO that we're trying to interact with right now.
And how would that work with the faucet params, with the other one?
We don't, all we need to do in that case is build a transaction that satisfies the constraints of those 5 params. Does it have this access token? Okay, you're supplying the Plutus script in the first place, and then this part, I need to have a better answer for you on where that information actually lives. I'm not satisfied with my ability to kind of talk through that right now.
Okay.
But it's encoded, right? I don't think it actually lives anywhere. It's kind of like writing a document and then getting the hash of that document. I don't need to try to reverse engineer what was in the doc. All I need to do is see that the doc produces the same hash I expect it to. So, so as I supply these as I supply these different elements to my transaction, it's going to look at what I'm using as the access token and what I'm using as the faucet token. And then it's going to say, okay, well, here is the address that these would have created. Do they match here? And we can say, okay, yes, they do. But yeah, I want to get better at talking about that part. But
So-
here, oh, go ahead.
No. I was just gonna ask, so I could add faucet params here and just add parameters to this datum.
So when you look in your compiler, the other file here, the faucet validator compiler, yeah, here you have those. No, you haven't, huh? Normally here you do those, you have to set those datum file here.
Yes. There's an
And
example of that.
And those parameters that you want to have in the datum are fixed baked into the contract. And so you can only handle those datum values that you have here in this, that you set here for the validator. So you would code in the parameters for this script here in the compiler. Exactly.
Whereas this is kind of made up to hook up to a front end, which is going to feed those values that are going to later be passed on to the script.
Yeah.
Okay.
So in the project 204 folder,
Yeah.
you can see an example of how to build the actual JSON object. Yeah, go to this compiler. And starting on line 28, there's this IO function called write PBL datum.
Yeah.
And it writes to a JSON file. And it's got this helper function, write JSON, on line 25.
Okay.
And then there's a set of kind of helper functions there on lines 18 through 23 that take any particular kind of data and format it in the particular format. You know, yes, it's JSON, but it's specifically formatted JSON that will allow us to write a viable datum hash. So let's try this bit right here. Okay. Yeah, and you can actually, you know what? I have to double check the imports on the project 301 compiler. Let's just use this file right here. Okay. So copy lines 28 through 36. And let's duplicate those.
Pass them here.
Now let's keep it in the 204 file. Just
okay.
We can add that. We'd have to double check the imports, and just to do this as quickly as possible, let's do this. Give it a different name. So write PPBL faucet datum or something. And then change the output file name as well. So we can call this PPBL faucet datum.json. Yeah.
And just run it.
PPBL datum. Where's he getting that from? This is a type, isn't it? PPBL datum. Okay. Yeah. And so, oh, well, sorry, I'm hurrying. I'm hurrying and it's not productive. So, okay, line 39.
Yeah.
Where it says PPBL datum, you'd have to change that to the faucet datum data type. All right, and maybe this looks similar to the way we handled passing those params before.
Yeah.
Right. And you'd have to import that, but you can actually just drop that data type in the top of this file or above this, and you would have access to it. And then you change lines 41 through 44 to match PPBL faucet datum.
Cool. So I would need to add this data type?
That's it. right? And it's actually going to look, it's going to look just like the old compiler looked in a lot of ways. Yeah. Yeah, that's fine.
And then I would pass it here.
We
Faucet
need
datum.
the unstable make is data to go with that. And here's the thing, once you do this once, you'll see what the output looks like. And so in my workflow, I like to use a function like this just to remind me exactly what that JSON is supposed to look like. But once I have it, sometimes I just go through and I change it by hand. I don't have to run the Haskell function to write the datum every time.
Yeah.
But it's nice to kind of see this process and to get the output.
Yeah.
So end of line 48 after the $, add that, what we call that data type up above.
I just need to make the Plutus TX lift. What is it?
Yeah, that's it. Hi, Sam, Sebastian, Curtis, Lucas, A, Dominic. Hey, everybody. Roberto gave himself the challenge of trying to rewrite the faucet contract to not rely on a parameterized validator, but to remove the parameters and think about it from a datum perspective. So we were just kind of having an impromptu conversation about that. But this whole thing has been recorded, so I'll just post this whole video for today's live coding session if anybody wants to kind of see this process on their own. That looks good. And then when it comes to writing the data, now we just have to replace those 4 fields with the 5 that we expect in the faucet. Yep.
Okay. Okay. All right. Should I stop sharing my screen?
Sure. I know we're well, we got a few minutes. Mix is going to come and give us a awesome deep dive into Plutus, but while we're waiting for him, you want to keep going and see if we can see this thing?
Okay, I don't kind of need to build this, right?
Yeah, here. Do you still have the?
I don't have the original. I do have it.
I got it. I got you.
Thank you.
So yeah, it's we can just copy and paste from the previous version of this. I'm just getting that on my end over here.
Perfect.
Oh shoot, you know what I just sent you though these are mainnet params because I was just playing with it differently on my end. Shoot, that's well, at least the format will work. You can I just sent you this format, but yeah, let me send you once again well, whatever, it'll compile. We don't have to, you can change the values later. Now we don't need on lines 50 through 54, we don't need the faucet validator script with pkh dot. We can just get rid of everything there. Yep. We do want the commas. Yep, you got that.
What did I do here? Oh.
Press press here.
Which is the one that
I'll show you. Do a quick Control Z or Command Z. And then when your cursor is just on the word faucet on line 50, you can press Command D just to highlight that word.
Oh, you're right. Yeah.
Right. And then just tap that 5 times. Boom. There you go. That looks good. Oh, we want space.
Okay, so this I should be able to compile this, right? I think I have a shell going. I do. Can you guys see my shell?
Yep. Yes, that'll take a moment just to load up, obviously, the first time.
Yeah. A little bit. Okay.
Hey, and welcome, everybody.
I'll keep it here just to be aware when it finishes loading. I had another question, if I could, real quick.
Of course.
I was trying to do the enable the just download the pre-production testnet. So I only have one node, and what I was trying to do is create scripts so that it would just point to different configuration files in different databases, and then export the different nodes. And it worked sort of well for the preview one, which was already working, but with the pre-prod one, I get a YAML error of mapping values. How can I show you? I have this script here. So I got this script, and I just pretty much pointed it to different configuration files. So if I go, and I run, I get this. I don't know if you can read that. It's too slow.
Yeah. Topology config. Did you download all of the files?
I did. I'll show you my folder.
Pre-prod.
Oh, it's here. It's here. So I have the pre-prod config.
Yeah, there's everything.
And pre-prod, a preview config as well. Oh, but I don't have the mainnet for the. Could that be the problem?
It shouldn't be. Anybody else seen this issue before? Mapping values.
How did you pull those files?
I got them from the. So there's an IOHK article on how to set up your Cardano for the preview, and it links to the Cardano World GitHub repo, I think it is.
Yeah.
Which has the. I'll show you. I think I have it open.
So you wgetted those files?
No. I just control alt clicked on the files to download pretty much.
So I had that same exact error when I did that. I did like Control A, Control C, and then created my own files. I don't know why that did not. That gave me the same error message. But if I wgetted the files, then it worked. I don't know what the difference.
Oh. Okay. I'll try that then.
Oh, I wonder why that's happening. Yeah, I like right clicked on them and saved them one by one.
Yeah.
I didn't have the problem. So similar, right? Why would that happen? That if you copy the data, I wonder if like one file name is off by a character or something.
Yeah. That's kind of what I was looking at right now with the files.
I wondered if it was because my primary OS is Windows and everything I'm operating is WSL. And I've seen this in the past where Windows creates empty characters. So like it's not a space, it's just literally an empty character. And sometimes Windows will add those, or HTML will add some formatting that you don't see in VS Code. One way around that is like copying and pasting into Notepad, and then copying from Notepad into VS Code. Sometimes that works. But wget just, I don't know, it just worked for me. And I used that same URL that you were pointing to, the dev world or whatever that one was.
This one, I'll put it there. This one, right? Can you see my browser? Well, it can't be another one. Can't be, it has to be this one.
Oh, no, it was the documentation link actually for environments.
Ooh.
You could try that. Yeah, that might work too.
This is what this pointed to.
Okay.
Oh, environments. Oh, maybe I messed up the files that I was meant to download. So what is the difference between Canada docs environments pre-prod? No, it's the same. Same one. I don't know why there's links to both. Why are they?
So yeah, you could try those commands that they have listed.
But does this work for Mac though? wget, isn't that Linux?
As long as you have wget, yeah.
Ah,
Which you should.
okay. Okay. Check maybe.
So you can see it created the .1 because you already
Yeah.
had the file.
Yeah.
I what I had to do was actually just clear out all my
The
config
original?
files and then just start over.
Might be easier. Okay. Let's try it. Script. This doesn't change. Okay, so the names should be okay. Ooh, it worked. But I need to change the, oh, that worked. Awesome, thank you. I just need to export the different, I need to point the node socket to the different path.
Awesome.
Thank you so much.
How's that Cabal REPL going in the other terminal?
Oh, that's right. Was it validator? I think it's, no, this is project 204. Still going.
That's fine. Let's just spin back to this later because that'll take a little while longer to load up. But hey, Mix, I know that we've got an exciting start to a series of deeper Plutus dives ready to go today. What's going on?
Yeah, first, hi everyone, hi James. Yeah, today I hope it would be a very good day about introduction to Project 303. And I hope I will cover the most of the topic I wrote about the introduction, but yeah, the deep dive would be, I mean, it would be great for today, but I don't know if we will do it today or not, because there is a lot to talk to make this thing ready for people first to understand the game and the game dynamics and the logic, what they should prepare for that. So yeah, I'm ready for that. So we can start it. And then if you have time, sure, why not?
Awesome. Yeah, I mean, we were talking earlier this week. This is probably what a 15-hour lecture that is required right now.
Yeah.
So we're gonna see how much we can cover in a little bit more than an hour, and then we'll figure out what we need to do next. Okay, so
Great.
we'll debrief at the end of this. And this session, as always, we're recording this. I'm going to post the link and a timestamp to right now, just for people who are taking on the mastery assignments for module 303. And then we'll talk about how to follow up. And just one quick personal note, I have to drop off for another meeting right at the end time today, so 1600 UTC. So I'll just do so quietly. And if people want to keep going, you'll be able to. Okay.
Okay, no problem.
I'll stop sharing my screen.
Okay, thanks. I will start sharing my screen. So can you see my screen?
Looks good.
Okay.
Perfect.
So first, I would like to point out several stuff. I added a course material here, and first, let's look at the repo. If you go look, this is the latest repo. I pushed the latest change around 2 hours, 1 hour ago. In course material, I would put most of the things that we were talking about, and I didn't put it in README or game instruction in 0.1 game or in Bounty Escrow. But for now, I've put the module topics and what we talk at least today. And I hope we will talk about all of this today. And then these are is for the next session, which will happen, I hope, at Monday. But which time we will start and create a pool for voting. I mean, you will vote and which time would be better, like doing same time, like as a live coding or later. We will decide on that. And then there will be more, but I just point out some of the topics, and then we will talk about more other stuff. And we'll have some fun session, how to hack or counteract, and how to actually bypass some of the security mechanisms that is already there, or we can change it. So yeah, without further ado, and by the way, all these materials again we will post it on Canvas too. So we will have in both places. So no problem, and you won't need to worry. And again, if you have anything you want to add or you want to discuss, I mean, you want me to discuss it more in next session, please let me know or leave a message in Discord and Canvas. And also, if we didn't cover any of these, this will be shifted to another session or another session. So yeah, I will try to explain everything as much as possible. So yeah, without further ado, let's start with that. So first, after pulling out this repo and updating, you will see this README, which is just a simple, very brief that saying that you need to go to the right folder. So end of this module, you would have to do 4 different assignments, which start from the easiest to the hardest. And and 3 of them are about Bounty Escrow. But the last one's about 0.1 game. So, and these 2 have some connection with each other, but don't worry again, we'll help you to do that assignment too. So it would be like pushing you into that some deep stuff and no help. No, it would be helpful. So the most of the module that we will talk about, it would be about 0.1 game, a smart contract, but we will touch Bounty Escrow too. And the reason is these 2 contracts have a different approach and design pattern and business logic. And as you guys know, that title of this module is about business logic inside the validator But in order to understand and how to see and how to conceptualize the dynamic of these stuff inside this validator, first you need to know some stuff, for example, the redeemer, what's underlying that, and how to craft this, and what should you put inside redeemer or datum, and we will cover all of this. So this session is about introduction, and we will start talking about this game and maybe briefly about the dynamic of this contract, and then we will go for redeemer, and then we will go for Plutus logic. So if you head to a readme inside a 0-1 game, there is an instruction how to install, and I hope this would be very similar, and you are already used to do it. That run in Xshell Plutus app. This repo is worked with the latest Plutus app, so you don't need to check out it at least. So if you have the latest Plutus app repo, it should work. But if you find any breaking stuff, just let us know. And then for the preparation, you need to get some values, some datas. And what are those datas? I mentioned here that first you need to mint a token, which is an NFT. I mean, it's supposed to be an NFT, non-fungible. You cannot repeat it. Why is that? Because we want to track the state of blockchain, the state of a UTXO by that. I will talk about more deeply about estate management and why we do need a state NFT, and what's the rule of datum. And here, what actually we saw inside the UTXO formal specification, that they said that, yeah, transition of a transaction, and we will look at in this stuff. These are the official document and formal document of IOHK, and we don't worry, we don't go very deeply in the stuff, this very mathematical stuff, but in order to know what's going on with UTXO model and account model in Ethereum, what's the difference and the state, you need to know some of the very defined words or definition that, like datum, they're official. But we will try to explore other use cases, how we can use datum or state NFT with other use cases too. And not today, but in next we will I will show you some example of a state machine library inside the Plutus tool, and what is the limitation. So anyway, for now, just mint a token. Mint if it is NFT, is close policy, no problem, but just mint a token and take the currency symbol and token name out of it. And here this simple command will convert the token name, which I used inside the compiler as I choose project 203 estate NFT. So you can, if you want to follow same thing, you can just copy that and bring it here, paste it, and done. And you can run this command and mint it. And I, for sake of simplicity, I just mint the token by a native script, or aka simple script. And I think you already know how to mint from this native script versus Plutus script. It doesn't matter that much which script you are using for this. But anyway, so the first step is this. Let's assume that you've done that and you have your currency symbol and token, and then you can head back to game.compiler, which will be in SRC folder inside game folder, and a game compiler. And here is a section of state NFT details. You just replace this and replace this with those values we got. And you can, again, choose any name you want. So the next step is for first player payment public key hash and second player public key hash, which I think you already know how to take that to and the command for doing that, but we can do it. But this is, again, we talk about it several times in other projects. So, but by the way, what I'm saying with payment pub key hash and pub key hash are different. We will talk about these type and why payment pub key hash or pub key, what are the differences. But for this 0-1 game, since we implemented security, let's say security check for function, we need a staking address too. And why do we need that, or a staking credential? To create Shelley era addresses. So if you look at in your address, let me show you here. This is my wallet folder. Let me just show you the address. So you're familiar with this kind of address. This address is called enterprise address. So in a blockchain like Cardano, which is proof of stake, this address works to send UTXO or to get UTXO, but it is not possible to stake to a pool with this. The mechanism for this is different. So in order to have a Shelley era address that you can see it in the, let's say, Eternal in your wallet, let me show you the Eternal. And let's say this is the mainnet. I just made a dummy wallet. If you see in the receive, you see that this address is much bigger. So at this, the size of it shows there is something more inside that. So what is inside that address is combination of your payment public key hash and this address. So actually you have two addresses combined and you will get a Shelley address. And this is the staking address, which will produce, which inside that is a stake public key hash or staking public key hash, or in other words, a staking credential. And you will see all of these words around this contract. And the payment public key hash here is not visible, but you can take it out. But for now, I don't want to go with how to deeper inside the addresses, what's going on and the encoding. Just follow these commands to create your first staking addresses. And I should point out that this SVK I added as a prefix, or so, let's say as a like a document file format. It's not actually doesn't matter. It is just for sake of recognition between the normal VK that you get and the staking. So you won't end up if you want to save same file name or same wallet name. For example, in my case, I just choose my first wallet as a 01, very simple. Like you can see 01 address 01 public key as 01. But if you want to do better name convention, go for it. But for me, I just use that for VK, like verification key for payment public key, just VK, and for the staking, just SVK. So it's up to you, and it's not mandatory, but just please remind if you want to use same full wallet name, do not overwrite your verification key, because if you lose it, actually you lose your access to that wallet. So just be careful about that. And then after creating these two files, by running this command, which is similar to the command that you get for payment public key hash, you will get a stake public key hash. And after that, you will come to game compiler again and change these variable. And if you want to play as a 2-player by yourself, okay, you have the 2 wallets, no problem. Just take out these stuff, this variable, just put it there. So any question regards to, let me look at any question, guys, regarding to this stuff?
Hey, Max, how you doing, sir? Really quick, so I saw how you generate that first address, and then what I just want to make sure is you're generating a staking key for a different parameter within the game. So you do need the first address, and you also need the staking key, separate entries.
Yes. Why separate entries? Because we will talk about deeply about this. Because so far in all the project that you have done, we were focusing on payment pub key hash or pub key hash. But now in this project, we are introducing you with this new era of Shelley era and a new type that's called address. So in order you get a new type, Plutus type address, you have to provide these 2 different hashes. Payment pub key hash and a stake pub key hash. And payment pub key hash, you will get it from the normal verification key, the normal VK, but the staking pub key hash you will get with this command, which is again is not exactly the same. Just Cardano CLI address and key hash and verification key file, you will end up with. Let me show you that. Cardano CLI address and key hash and dash. And if I just enter it, I can see, okay, these are my available function. And as you can see, you see payment and payment dash verification dash key dash file, and I will provide my normal VK. And this would be your pub key hash or payment pub key, sorry, not pub key hash. The underlying type is the pub key hash. So even if you mistakenly using this for a staking, this compiler would not complain, or you will not get any error, because the underlying type of these both payment pub key hash, stake pub key hash is pub key hash. So the type of these 2 are same, but these 2 payment pub key hash and stake pub key hash is at some higher level type. So just be careful about that. And for getting the, go ahead.
Oh, thank you so much. So you could use the long form, like the ADDR version, and it would still process, it would still work.
Yeah, but I will show you in a future session. I don't know about today, but just I will briefly show you today that why we use this. I mean, what's the point of using this, adding more complexity, or maybe even actually even more computation level. And because of this security concern, what's actually happening in proof of stake Cardano, and these three function that's checking the address. So this is not just checking the pub key hash, but the staking pub key hash too. But if we don't have these, let's say, and we will comment this out in I will show you comment this out, and then you will see that in fact, let's I have the both address, and again let me show us 01 ADDR. This is my enterprise address, and I made a Shelly address with SADDR, and again this this .scdi is just for sake of recognition. You see that these two are different, but if you see there is some similarity between them. The similarity is the payment pub hash, but just I added the staking part. So yeah, these two, if we don't have this guard, let's say the security guard will work, and that's bad. And I will tell you why it's bad later, and that attack surface that can happen. Not only about a staking board, but about the depth in future you are going to build on Cardano and the staking part of your contract. Because in fact, your contract is actually is a wallet. So you can't stake your contract to a pool. Then you have to know how to stake your contract and how to deal with this and so on. So yeah, I mean, this project would be an introduction for you guys about the staking part and proof of a stake of Cardano, how to deal with that and so on. So anyway, just for today, just follow and create these stuff. Just put them here, and in game instruction, I think I created the command, or forgot, I think in README. Yeah, here. Here I create the command, and I put the command for how to create this address, how to combine your address, how to combine your payment pub key hash and your staking pub key hash and end up with this. So yeah, just follow that. And I will remove this because a staking address and Shelly error address. In official talking, people are referring, but for sake of this course, I will just say the Shelly error address. And when I say a staking address, I will refer to the staking part. Which I mean, for example, this address, you can see a stake key or a staking address. So your payment address would be something that you already did many times, and the staking would be this new stuff. And then after running this command, you will have Shelly error address. So yeah, 3 addresses. Any question? No? Great. So after doing this, and you have all these factors, now there is 3 variables that you need to put to. In order to this game works, I mean, that's the game, you need to put a bet amount. And this is the amount that both player will put their money. So, you know, the game would be worthy of play, you know. So I just put the 3 ADA. You can, this is 3 million Loveless. You can add extra, and you can go lower. But I think I found this lowest and the most optimized value, because if you go much lower, like 1.8 or something, you might hit the minimum UTXO value for the NFT, because we are having NFT in this circulation. So I don't know if it's up to you, but we can keep it here, we can change it. And about this time, POSIX time, if you go to this website, just a simple website you can do in anywhere. But we will talk deeply about time handling, how to do with POSIX time inside the Cabal Ripple too. But for now, just use this website, and I give you a refresher, you will get the current time. go for the GMT or UST time, because the node, your node have the time inside your node is GMT, it's UST, it's not your local. So just let's say the now is this, and I will, let's say, I will add 30 minutes for the sake of the game, for the end, the game deadline, and I will, I don't know, let's you will take this number, just come in here in compiler and just paste it here and done. And for reveal, which the first player will reveal the choice, and we will talk about the game in coming minutes. Just change, for example, let's say 25 or 15 or anything you want. Then you are good to go. And just again, human data time step, copy this amount and come to here. I want this, I won't put this now, because if I put I go to, now I want to go to explanation about the game instruction and how the logic works. So if I compile now, we will pass the deadline and we cannot actually play it. So yeah, if you do this, in fact, your everything about the contract is ready. And then by running cabal repel and then calling this function, write 0-1 gain script and getting this right, you are good to go into game instruction. And I pointed out that there is 3 different script, Haskell script inside this project that we will talk about them. But one of them is data to JSON, which is different datum and different redeemer for different situation of game, which we now will talk about and what this situation will be. So just by going inside your cabal, inside the place that, 0-1 game, and running cabal run data to JSON or address info, the name of the script, I mean, you will run, in fact, the script, and it will automatically take the options from what we provided here and create all these redeemer and data and these stuff inside the output folder. Again, but at the end, it will tell you that, this JSON file there. So, okay. And so this is about that. And let's head to game instruction file and talk about the game itself. But any question? No? Okay. So the game, 0-1 game, the logic is similar to rock, paper, scissors, which 2 players have a choice, and the player must guess the opponent or the other player choices. But in this case, we have 2 options. So the first player, and the 2 options are 1 and 0. And first player will choose a number between 1 or 0, and that number is what the number second player might choose. So the first player must predict that second player will choose 0 or 1. So if a second player choose 0 and first player did actually choose 0, so both options are same, both numbers are same, first player will be winner. But if first player choose 1, for example, and second player choose a 0, second player will win. So that's the logic for this game. As you can see, I wrote it down that this choices of same option will be the The winner will be first player. If it is different, second player. But here in this game, we are using Datum to put our choice. I mean, the first player choice and the second player choice inside. So if we put just very simply, like here, this is the datum for the first player. Let me format it and sort it. By the way, based on the RFC, I forgot the name, the order of object inside JSON doesn't matter. So if the constructor is here or field is top, or if I sort it now, this is top, it doesn't matter. So don't worry. So, and we will talk about what's going on, what this constructor are, what's feed, and so on. But let's say this is the byte, and I just put 0 as a first player. Well, in order for second player to play this game, he has to get the first datum, right? I mean, the hash of datum is inside the UTXO. So somehow in off-chain manner, I have to send this datum to the second player. So second player can submit that, which you can see in this, in here, after the first player start the game, for second player start to play, we can see that a start datum, which will use this file, this JSON file, must be provided. That's the rule of the transaction. So if I give the datum to that person, to second player, and the choice that I put there, that's 0, 1, well, definitely second player would choose differently, and always he or she will be the winner. So what's the solution for that? The solution is we call in cryptography commit scheme. So instead of doing or putting your choice or anything inside the datum, we will hash it, we will encode it, and then we will put that hash and that encrypted string inside datum. So the second player will not understand what's going on. But there is there is another problem. Hash function is normally a one-way function, and it means that you cannot decrypt it. But if you provide same string, you will end up always same hash. So if I put just 0, let's say this is the player choice in this file, and I just put 0, always I will get same datum and same hash. Same hash for 0, same hash for 1. And they are different, but same. So again, after some time, the second player will understand, okay, there's a pattern here. So again, he or she will understand what's the choice. So again, what's the solution? We will add something called nuance, which is a short abbreviation for number ones. And this is for now, or you can actually change it, this nonsense with whatever you want. In fact, if you want to play with different person, you have to change it. So you will end up with different hash. We will put a series or arbitrary string. It can be, I just put any character that's a possible number, letters, and even a special character. And this function, SHA-256, which is a built-in function inside Plutus. This function is different than a function, a SHA function in normal or in cryptic word. This was written specifically and especially just for Plutus core. Not if you run this, I just made this. So if I just made a script like create a hash of function. So this is just simple a script that take a player choice like 1, and then let's say to combine it with nonce with this string, and then produce a hash. And let's just see how does it look. So cabal run and create hash of answer. So you see the answer actual will be combination or this string plus this string. By using this function, again, this is the Plutus function. That's why I imported Plutus TX, applied byte string. We will end up with just this simple string. And then SHA-256 will hash that to this. But if you have seen hash before, this doesn't look like a hash or a normal hash. What is it? In fact, it converted to a hash, but an underline that hash again converted to something that Plutus core will understand. And the Plutus core is a different language. It is a really different paradigm. And in future session, we will look at Plutus core because there are some security concerns about that. And I will show you how to get your Plutus core and how to observe it, how to actually see that security issue about that. But anyway, this will be inside the Plutus core, and the Plutus core in its final form is untyped. So imagine there is a language program now that there is no type inside that. So it's like just series of bytes, nothing else, no type. So this will work inside that. And there is another function which is called SHA-256-2. That would create much harder hash, like it is better. But the problem is if you use that, your fee and not the Plutus size of the Plutus code wouldn't be that much bigger, but the step for the execution of your script become higher. In fact, I read somewhere 2.5 times. So if you can go with this, go with this. I mean, you don't need to go with SHA-256. So this function will hash or answer, and as you can see in data JSON, this is same as that, and put it in a start game datum. And this is in fact the byte string of this thing. And I really should call this thing. There is not that much name for this. Because if you can see, there is all sorts of character inside it. So now the game looks fair. So this is the top. This I talk about all here is what I talk about right now with you. So let's play it. But before that, do you have any question regarding this stuff? No? Great. And so let's start the game. But by the way, someone say something. I'm afraid that did I disconnect it?
This is amazing, dude. No, keep going. This is awesome.
Okay, great. So let's play the game. For first, I put this my variable that's it's this first player. By the way, in this game logic, in fact, you don't need this. I mean, there is no any function that will use a state game public key hash for second player. But it's a good practice to put it, and maybe you want to use it after learning about these stuff and how to work with address type from now on instead of payment key hash, then it's a good practice to add all these together. So anyway, I just put these hashes from those two wallets that I showed you, the 0-1, which represent first player, and 0-2, which represents second player. And I choose these 3 ADA here, and let's change this, and let's change and choose a deadline for our game. Okay, what's the current time? It's 8:15 GMT. Okay, let's add 30 minutes for reveal time. Sorry, minute. What? Please check your input. Okay, so sorry, this was the hour, and okay, the hour 3, and the minutes, let's say 4. This would be for reveal, and I will copy this. I will put this in first player reveal deadline. And by the way, I especially choose these very long and lengthy names, so it would be more clear for you guys going through these script or these variable. But sure, you can, and actually that might be your doing, or not the assignment, but we can do this, reduce this size of these, like just 2 or 3 character as a variable name, and see how much changes happen to your Plutus code and how much changes happen to your feed. So if it is too much, if it is happening, if it is no change, so we can decide to choose this kind of naming convention or smaller. Anyway, so now for the game deadline, I will choose this, but let me change it. Actually, let me go for 15 minutes for the game. So what was the, okay. You see, this is sometimes giving me AM, some now is giving me PM for some good reason. So okay, so now is a 15 and minutes is around 30. Okay, I said 45 for reveal, so 15 minutes from now for review. And 30 minutes for deadline. But did it actually change? Yeah. So this would be similar. I already minted my token. It is resting my first player wallet. Just let's go and compile this. Right, 0, 0 game script. Now I have this message. This warning is actually is because I use so many stuff and change the stuff. So there is some file that I have to clean it. So if you run cabal clean, it will fix these errors. It's not the error, it's the warning. But if you clean that, you will actually remove all the installed packages. So you have to run cabal repair and install it. So you can just ignore it. It doesn't matter. So I got this right. So it means, okay, I'm good to go. Now let's create an address out of it. This is, I already made echo, let me show you echo file name. which will 0, 1 game. And by running this command, I will create the address for that. And then I will copy everything in this folder, which is output, into my wallet folder. So I can do all the operation inside that. But you can do you can do opposite. You can put everything or the verification keys inside output folder, or you can just give the relative pass or absolute pass in it should be absolute pass inside those parameters that we're going to see. But for sake of simplicity, I just copy everything to my wallet. Okay. And now let's go for the first playing. So by the way, I ran this script too. So after the compiling, I ran this script. All the redeemer and datum are already there, and then I sent that. I'll send all these files to that folder, to wallet folder. So first player start the game, and here you have to be careful. Why? Let me show you. So let's head back to wallet. Let me query the wallet. UTXO 01, and you'll see, yeah, there is some stuff there. And in fact, that I played that game before, but this is the NFT. This is a UTXO that holds NFT. So the thing is, if you send your NFT, it has to have 2 ADA. And why 2 ADA? Why not 1.7? Because inside this contract, we've used something called min ADA TX out. And min ADA TX out is a function that use the minimum amount of ADA is possible. So it is hard coded inside that. So I won't show you now because we might pass the deadlines. But just remember, if you use this min ADA TX out, and min ADA inside Plutus means 2 ADA, not 1.1, 1.2, but it means 2, absolute 2 ADA, and it is hard coded. They haven't changed it. I don't know why. Maybe they will change it, but for now it is 2 ADA. And in this logic, bit will be added to this minimum amount of ADA that carry the state NFT, and the first player has to send it. So let's say the bet is 3 ADA. So first player has to send 5 ADA. So at the end, if second player win, second player will send back that ADA along with the NFT to first player. And in order to do that, he has to give 2 ADA. So it would be not fair to second player to spend or to give 2 ADA from his wallet. So at the first start of game, with this game bet or game amount, we will add 2 more ADA to carry the NFT too. So that's why I here very clearly I specify that this is the 3 ADA for first player bet amount, and NFT ADA amount is 2. And this is a simple arithmetic. This is the tool inside the Linux that do arithmetic. You can add to number or subtract or divide or whatever. So this just for the sake of that NFT, and you will see that how this NFT play out. Anyway, just let's put this TX in, which means a transaction ID that we are going to send 3 ADA, and we want to spend or take the fee from it. And what's the TX? Okay, the ID is 0. Okay, NFTTX is in fact this one. And the ID was 1. And everything else is estate NFT. Estate NFT means the whole of this string, which is the policy ID dot the name of the token. As you recall, the name of the token was long, project 303 estate NFT. So you just put this here, and the first player will be 0, 1. And when I put 0, 1, it means it will substitute this for address, for S and signing key. So I just made it simple. So anyway, let's start the game. And here, as you remember, we send that address, game address contract is here. So let's do this. The magic, I already did it. I mean, I have the magic already in my profile inside Bash. So now let's run the command. And we'll take all of these, since we are very sure about the command. So yeah, you see this Lovelace, it is accepted, everything's work, and here I will sign it. So now let's see when this UTXO arrive at a contract address. So 0, 1 game. Oh no, for now. Still nope. Let me see the note. Still is here. Didn't confirmed. I think it confirmed. No. Yeah, it did. Okay, I think we are good to go. Yeah. So let me clear it, and again query. So now this is the UTXO for the game. So a reason we will talk about estate management and estate NFT and using all of this stuff. But imagine this contract has hundreds of UTXO because many players are playing. Estate NFT helps you to track a specific UTXO, not in off-chain code. Like you know, you can find it. You can find it through your serialization library or through your some script, but you have to give this information to your Plutus code. So your Plutus code must know that when it's validating a UTXO inside its contract, in fact, it is validating the correct UTXO, the UTXO that is supposed to belong to first player, the first player and the second player that we specified here. And in future, you can remove this and put this, and this is actually your assignment, fourth assignment, that's removing this contract parameter and put it as a datum. So you will end up with a static contract, and any player can add this stuff and play with that contract. So your contract must know, but the contract for now at least is not like Ethereum. And estate the contract doesn't, it's completely blind to the changes on blockchain. So the estate NFT is a one way to help this contract to know that, yeah, I am dealing with the UTXO. See, there is error here that says that first player bet UTXO is wrong. Although that UTXO might exist inside the contract, but it is not the one that we want. So that's one of the purpose of the estate NFT. So now let's go for the second player, start the playing game. A second player must play the game before the game deadline. But how do we do that? How do we tell our Plutus script that what time we are, and how we tell in fact that we are behind the deadline? Because if you recall, we should play this game before the deadline. Some of these options that we'll explore together must happen after deadline. And these two are different. And these two have different switches and different logic behind them. And now we will focus on that. But first, let me just put this variable. So first, TXM. Let me query the second address, second player wallet. Sorry, it's 20, it should be 20. Well, you see, I played a lot of, and there is a lot of winning bit. So I take this UTXO, should be 0 contract TX, hash. I will take this, and the TX ID is 1. So hashing 1. Contract file should be in your folder. Datum is same. Second player, the collateral will be this 5 UTXO, this 5 ADA, and the hash is 1. And we will use a play datum, play second player play choice datum. It is different. We will go through that, but let's just play the game. And the bet is 5, and game UTXO is 5 because 3, as you can see, 3, which is the bet amount, plus the 2 ADA, which will be carried NFT. So game UTXO is 5. Second player bet is 3, so it combined would be 8. So, and I will take this state NFT from here. And then second player would be 0.2 and a slot. For getting the slot, I will query the blockchain. Tip, in fact, since we are tipping, we'll take this slot. And now this game deadline slot, and we will use invalid here after. Just let me finish this, and you will see. How much was the, I think was the 30 minutes from now. So I'm adding, this is the second. This is, for now, a slot means second. So each second add. So now I'm adding, let's say 30 minutes. It would be 8,800, but I want to be some lower because we spent some time. Let's go with 1,000, I don't know, 400 something. Okay. So again, I will explain this later to you. Just let me copy this stuff here. Okay. Now let's run the command and see it works. I hope it works. We didn't pass the deadline. Yep, we did. So let's try it and see if I change this to 1,000. Okay, we still reached the deadline. Let's add 100. We still reached the deadline. Unfortunately, I think we passed the deadline. Yeah. So we cannot play the game. But anyway, I should have chosen much longer deadline, but I think it's weird.
Been there.
Yep. Okay. Anyway, so let me show you what's going on here. Actually, why we do it's invalid hereafter. What's the difference? There is another. Well, okay, actually, let's go for the choice that here I explain it that imagine the second player doesn't play. So in our scenario, second player didn't play before the game deadline. So what will happen to that UTXO inside the contract? So now the first player must have the choice to redeem or to get back that UTXO along with the NFT to himself. So inside the game contract, that would be this option. And again, we will talk about it very deeply, but this is a claim by first player. So let's go for that. Let's claim that. And you will see a different flag, different switch for giving the time. And why? Because now we want to prove that the current time is in fact after deadline. So first player start game, first player did the choice, we passed that. So now we are with these options. So let's done this. First, let's query the first player wallet. So, okay. So I will choose this as a UTXO that's going to pay for the fee, and ID was 0. Contract, I think still we have it. No, but let's query it again, no problem. Let's query the contract 0, 1 game. This is the contract. And take it. I hope it was 1. So the contract file, a start date, because no changes happen to that, and we are using different redeemer, which I call first player claim redeemer. We can just go visit these files and see what's going on. Collateral, that would be this UTXO. And it was 1. So the bet amount which first player put was 3 ADA. The NFT amount was 2 ADA, and this would add that. A state NFT, okay, that would be this thing. And a start game datum. In fact, the hash of that is this. This is the hash of that datum, a start game datum. So that's why we have to provide every time. So first player will be 01, and the new slot now a slot number. Let's query the blockchain. Tip. So now would be this slot number. And let's take this. And let's go for this command. But as you can see, there is a difference. Invalid before. Now, after submitting this, I will go explain deeply about these 2 different flags. And see, yep, that's worked, lovely, done. Now the first player got back the amount. So this option that the second player didn't play the game before the game deadline work out, just as you can see. But what was those flags? So let's imagine this line is the game deadline. Say a game deadline. So inside your Plutus code, there is 2 different functions. One here is checking the game deadline has been reached, which means the second player didn't play the game before the deadline. So again, before the deadline. So we use, if you see this, this would be same with this function. And this is the one that we use right now. The game deadline has not been reached. So this option must be available, or this must be valid after a deadline. So the difference is, this is the same, but the difference is to and from. So we will talk about that in future, about time handling and interval. But the thing is about these thing, these contain is comparing two range of time. Let me show you. If you go with Plutus, which I call it Plutus Holy Book, if you go with Control S, you can search it and say, let's go from. This is, I think, the Plutus ledger would be, this is V2, V1, I think the ledger. Let's go with the ledger. So this is the one that we use, and this is also the one that we use. Interval inside Plutus means a range of time, means a start from a number and finish a number. This is a range. So there is a function that you can create this interval, create this range. But here, what we choose for 2, it means that first, before going to and from, let me explain the contain, which both I used. It's this game deadline contains this TX info valid range info, which means TX valid info range, if you just provide one of those flags, it means from beginning or genesis time or beginning of time until that moment, until the time that you are providing that time. So the range starts from, I don't know, 0, let's say, from the genesis time, the hard fork for Alonso until now. And this is again an interval. It is again a range. The range from, again, start from Alonso until the deadline that we specified here. So now we have 2 different ranges. This shows that the first interval contains the second one. So second one must be smaller than the first. That's the whole idea of this. The A contains B is true if the interval B is entirely contained in A. So what's the B? This is the very Haskell way, but let's write it down, that how actually looks like. So if we say this contains first, it would be this parameter and work as A, and this would be second parameter which works as B. So the whole idea of this is containing the norm, the range, the interval, the timing from the beginning of time inside the deadline. So what's 2? Let's look at that. 2 means it's an interval that includes all the values smaller than equal A. So I'm sorry again. This is actually should be like this. This is the first parameter. Just missed that off. So if you provide 2, it means from the beginning of the genesis, the beginning of time, until the deadline. But here, if you provide from, it means, let me write it down like this. It means from the deadline until the end of time. So the difference are these. So if we want to say, okay, something must happen before a deadline, we will use two deadline. And if we want to do something after the deadline, we say from deadline. Deadline. And then that contain shows that does this two from the beginning contains this. If it is true, so this function, this error won't happen. Why? Because the range which we provided from the beginning of time until that time that we were giving inside the Cardano CLI command was smaller than beginning of time until the deadline. So let me write it here. So tx info valid range must be is there any? No, there is no. That's it. Is there any? Okay. Okay. I wanted to use a smaller or similar, but this should be a smaller than to deadline. And here it should be completely opposite. So if we change this, we say from deadline. And sorry, this should be again should be this actually. If you use contain, it must be this. I know it is confusing. To be honest, it was confusing for me too, and I don't know. I'm doing great job for explaining this, but the thing is, if you want to use a function or you validate something before a deadline, we can go with this kind of function. And if you want to validate something after a deadline, you will go with this, which is saying that this from and until the end of the time, and to is from beginning of time until the deadline, from is from the deadline until the end of time. Anyway, so if we want to provide time, we have two switches: invalid before and invalid. And here would be invalid here after. These two determine the time that respect to deadline. So it say as actually this transaction is invalid before this deadline. So if we provide this with the current time, this transaction should not be valid before game deadline. That's why we use that in this file. Where is it? The first player claim. See, invalid before. So this means this transaction must be invalid And it was, because we already passed that, and it wasn't invalid because we already passed. So the transaction was valid. Why that one wasn't working and was showing me that game deadline? Because invalid hereafter means the transaction must be invalid from the deadline to end of time. So invalid before, say, everything behind this line must be invalid. Here, invalid hereafter, say everything after this line, which is a deadline, must be invalid. So by these two switches, we will tell the Plutus code that the timing we have is, I mean, what time is it in fact? So, but if you recall, I added some numbers to it. I just add extra number for invalid hereafter. Why? Because in fact, I have to show what's the deadline is. So when I add, let's say this was the POSIX time of 1000. Let's say the game deadline is at 1000. So anything here must be above 1000, 1001, for example. And anything here must be anything less than that, 99. But one thing that I noticed, you cannot put the present time, because since the present time is going fast and the second is going, if you put, like, let's say the present time is 1, until you submit and gets the node, this is actually doesn't work. This actually, you are saying that from this second, this transaction is valid, and you already passed that second. So just don't go with the now, which I here, sorry, here I specified a start number now, but here is a reveal deadline, or here I said game deadline. So if you go with this number before starting, not just even before, even just to get in, put in this, writing, you already passed that time. So if you want to work this out, choose a number, add this with a slot number just before your deadline, just like something like 990,000. And that would be possible. But if you want to go with the other option, just invalid before you use this switch, because you want to say that my transaction is valid because we passed the deadline. So please ask a question. Okay, James left up. Okay, guys, do you have any question? I know this was confusing and I didn't do very great, I know. But if you have asked question, please, and I will try to explain it better or deeply. But
so it's basically just putting a smaller POSIX time value than your range for. So your info valid range has to be smaller than the value of your deadline into deadline, and your TX info valid range needs to be greater than your from deadline.
Yeah.
Okay.
This is the logic. I know this logic doesn't make sense, but this is the tool that we already have in our disposal in this handling time with Plutus. And again, I know that this, for example, there is a before function too. Two always never overlap like before, but it doesn't work. Why? Because you need to check a value with the first value of another range. So if you want to use that, your this function will check your game deadline with first value, the first, let's say the range has two values, the beginning and the end. This before will check just the deadline is less than the beginning of that range or not. But as you guys again know, always this is the case that if we, by the way, you can provide these two flags too. And in fact, in sometimes you have to provide it. But I will tell you why. I mean, you have to provide. But again, in normal cases, this will check your deadline with genesis time. So it always gives you false. And what is after checks, if you go with this range, after checks your deadline with end of time, which is actually kind of is infinite. So again, this cannot work with the logic that we choose with that game logic. But how we do use this after and before, if you specifically write down like hard coded or something, get the value, and you specify the range. So if you specify the range, it is not from beginning of time until the current time. It is from a time that you specified as a beginning, and the range and the ending again is somewhere as you specify. So you cannot use TX info range for doing that. You have to just you have to use some of these functions to create that TX info valid range. But you can manipulate that TX info. How? If you want to use this member. Member means that a value is member of range. So let's say that you let's say this is actually a real world example. You want to put a deadline for a minting NFT or minting a token. You don't want to go from beginning of time. So you want to say, I have a specific, so this is not a deadline. You have actually two time. It is a range. There is a beginning for the NFT minting and there is an end for NFT minting. So how do you give that range and how that Plutus validator will deal with that? You can use member. So inside this Cardano CLI or in your front-end project, instead of just using invalid before and invalid after, just one, you will use both of them. And invalid before would be your, invalid before would be when? Invalid before would be the beginning of your time, the beginning of the minting time. And invalid hereafter would be the end of the NFT minting time. So by this, you are actually giving a range. And then inside your Plutus code, you are saying, does this range is inside the range that I specify or not? There is some option for that, but it depends on you and how to want to do that. So invalid before, you can use this stuff. You can use these flaggers to give a range. But if you do not do that, it would be from the beginning of time for this, and here would be the for end of time, like from 1001 to infinity, and here would be let's say here is let's say from 0 to 1000. If you do not provide this flag, but in this case, it would be until end of time or infinity or end of time. And again, I know this is confusing. It will take times to wrap your mind around it. And yeah, that's the current way. But we can again compile the game going for that. Just I wanted to, I mean, let's say I know that I passed the actual current available time for this session. So I won't go much deeper inside this stuff. Like, but we are specified and we briefly touched this down, but I think we covered all of this. So if you have any question, please ask. And again, next week will be this session just focusing on this and going deeper inside all these functions, all these logics, and all these logics behind these different data you saw in output and how to build them, what's underlying there, what are these functions, like for example, why they call this unstable, what is unstable about this, and so on. And some boilerplate, and most importantly, you will get introduced with parameterized reader, which as you can see. Okay. So please, if you have any question, ask me or write it in chat.
Mix the step-by-step instructions are in the README, right? That's in the repo already.
Yeah, that all are in repo, and I can show you that here. If you go to the 0-1 game, you will see the README for which I explained at the end of the beginning of this session about how to make your contract ready or how to start. I mean, the preparation for the game. And after that, I again said that you can head back to game instruction and read the logic, which I explained to you about that. And this how to play again, I specified that you have to provide this stuff if you forgot it. And then this would be the options, that the situation and the condition these games might play out, which we discovered, we explored together. Second player didn't play, first player took that. Another option, second player play that, first player wins. What will happen? Another options or another situation, second player play and first player lose. How to do that? But you should remember that if you want to play different games, you have to come and change this choice. Just if you change this choice, you can do all the game. But if you want to explore more, like changing these nouns, and it's completely okay, you can just change it to whatever you want. It works. But here I wrote that the second player choice is always 0. But if you want to play with your friend or someone, or you want to make it different, you can choose here as a 1. And 1 and 0 are type. And we will explain, I will explain, we'll explore it at how this is a type and how this type will transfer or convert it to a number. So your Plutus code will understand. If you provide type 1, you are actually meaning that number 1. So it's not just a silly type. It is connected, that is related to a number. And I can just show you that that was here, that's defined here. So BS means byte string 0, because in Plutus code, you cannot use byte string. You cannot use literal string, which is this. So you have to change it to byte string, and that byte string to built-in byte string. Built-in byte string is a specific special type for Plutus code. And then we will lift this and add it here, as you can see, directly inside our Plutus code. And again, when I show you the Plutus code, the actual Plutus code, before going to compilation and before becoming something like this, you will see that all these stuff, all these variable and all this, you will see and you will actually love it. It's really beautiful code. So again, if you want to play, just you can just change this number and run this script. Everything is automatic. Everything you need is here. Or we can just tingle this. By the way, if you want to choose one for second player, you have to choose these two. Because again, in this project, we are going to learn how to connect your Datum and Redeemer, and they work together. So in this contract, game Datum and game Redeemer are entangled. So if you, for example, if you say just one, which is the choice of the second player and 0, that wouldn't work. The second player cannot play, in fact. So yeah, just remember this stuff. And again, we will talk about this deeply. Just explore this. And so if I just put 0 and here is 0, 0, first player wins. So if you want to play the fourth option, that second player wins, which actually this this security check will play out, which you have to provide the Shelley address, not the normal address. This change must be different, but it must in a game. In fact, in this logic, when we use underscore, it means whatever happens, 0, 1. So the choice doesn't matter here, in fact. So if the choice is same, let's say this is 0 and 0, but the first player passed the reveal deadline. So the first player didn't reveal his choice and passed that. And the game deadline also was passed. But here I didn't put the game deadline for that. We just after reveal deadline, the second player can claim the winnable, claim the reward. So you can just play this out, but you can point me out if you see, I don't know, some problem or something doesn't work. But yeah, but I just recommend choose a very, don't choose like what I did at high scale line. Choose for this 30 minutes and the game deadline. A game deadline, like, I don't know, 45 minutes, 1 hour or something, and this for 30 minutes. So you have a time for it, or even longer, 1 hour, 2 hours, something. So you can see that what's going on. Okay. Okay, see you guys in a song. Thank you, Dagbir. So yeah, guys, that was all. If you don't have questions, let's wrap this session and see you next week. And again, we will provide a tool for voting which time. If you like this time, same as the live coding, we will go with live coding because we will start this session at Monday. But if you prefer more or later, okay, no problem. We will see. Okay, see you. Have a great day, and thank you for listening. I'll see you all on the Monday. Bye.